Okay, so I wrote all the equations up here. We've got our key box up there. I thought I'd show you this with actual numbers and talk about one more thing here called pretest probability, which really will become key in understanding how difficult it is to test a large group of people for something. Down here I wrote the abbreviations: sensitivity, specificity, positive predictive value, negative predictive value. Let's look at this with real numbers. So let's imagine we got 100 people. And of those 100 people, we're going to test them for the condition, and the test and 20 people have the condition. And our test is pretty darn good. It catches 19 of them. So those are our true positives. It misses one. Somebody had it, we missed it. That's our false negative. And then it's for specificity, all the people who didn't have it, it accurately said that of the 80 people who didn't have it, 78 don't have it. Unfortunately, there were 2 out of the 100 that it said had a positive test, but they didn't really. That was just the unfortunate, it called these people positive and they weren't. Okay? But still, overall a good test. You know, it caught 19 out of the 20. It only falsely labeled 2 as having it. Okay, I've done the calculations already. They're up here. But our sensitivity, that's about 95% accurate. Our specificity, 97.5. Our positive predictive value, 90.5. And then our negative predictive value, 98.7. So that's our best test in this scenario. So if someone took the test and got a negative result, they can have almost 99% security that that's a negative, accurate negative test, okay? Not too pretty of handwriting, but you get the idea. So pretest probability, think of that as the prevalence in the community. And this is really, really important. This is why when you go to your doctor, it's not recommended just to have large panel of tests. And what this is referencing is how many people in that population or demographic have the condition. So for example, let's take something like checking. It's recommended for us to check for chlamydia in women in their 20s, all right? Now, you got to take outside of Utah. Yeah, that's considered a decent, high enough prevalence that it's considered smart to check for it. Now, let's take a blood test for ovarian cancer. As important as ovarian cancer is, its prevalence is not very high. And so if you check all women for ovarian cancer, that leads to problems because your pretest probability is not very high. And this is why medical tests should really be selected to high-risk groups. We're going to show that in our next little video with some mathematical numbers so you can see that. But this is a big reason why it's not a smart idea to get large panel of tests, because if you do those on everybody, the prevalence of that condition becomes so low that your accuracy of your test is quite poor. You can stop.